Hi guys, this is Dipanshu. Welcome to Mechanics of Deformable Bodies Lecture 2. In earlier lecture we have studied internal loadings and external reactions at support are produced in a body if we apply external forces to it. Okay? So due to these internal loadings which are produced due to external forces, some stresses are developed inside our body. So these stresses are of two types. First is normal stress, sigma p. Other is shear stress, tau. So in this lecture we will see generalized stresses that will be developed inside a body. So for this we will consider a three-dimensional body and we will consider Cartesian coordinates like this. This is z direction, this is x direction, this is y direction. So to find internal loadings inside a body, we will cut this body like this from xy plane. Okay, so this will be xy plane. Okay, we will cut body from xy plane. And also remember, on this body external forces are acting like this, external forces are applied. Okay, now we will cut this body from xy plane, so it would be like this. These are the external forces applied. So due to these external forces, internal loadings are developed, and due to these internal loadings, resisting forces are developed. So resisting forces are nothing but these are the resisting forces in any direction, so that sum of these forces and sum of these forces, vector sum, are such that body remain in equilibrium. So again consider a area delta A, smaller area delta A, which is in xy plane. Okay, and the force acting in delta A is delta F. This is resisting force due to internal loadings. Okay, so delta F is nothing but delta F is equal to delta Fx I cap plus delta Fy j cap plus delta F z k cap. Okay, so this we have taken out. This is delta A area and this is delta F, and delta Fx is in x direction, delta Fx, and this is delta Fy in y direction, and this is delta Fz in z direction. So you can see that these two, delta Fx and delta Fy, are tangential to this delta A. So these are called shear force because these two are tangential to this area delta A, and this delta Fz is normal to this plane. So delta Fz is normal force. So due to these resisting forces, shear force and normal force, stresses are developed, which are, first one, normal stress sigma p is equal to normal stress. Normal stress is nothing but resisting normal force divided by area. So it would be limit delta A tends to 0, delta Fz into delta A. Okay, so next is shear stress. Shear stress in this x direction, in xy plane, would be tau zx is equal to shear stress is equal to limit delta A tends to 0, delta Fx, that would be resisting shear force divided by delta A. Okay, so tau zx is shear stress in x direction and in the plane perpendicular to xy plane. Okay, so next shear stress would be tau z y is equal to shear stress in y direction and perpendicular to xy plane in the direction of z. So this would be limit delta A tends to 0 delta Fy divided by delta A. Okay. So these three are generalized stresses inside a body produced due to these resisting forces. Okay, and these resisting forces are produced due to internal loadings, and internal loadings are produced to make body in equilibrium because we have applied some external forces applied to it. Okay, so we will end today's lecture here and we will continue in next lecture.